All right, welcome everyone. This is Mr. Wendell. I'm here with Mr. Schindel and Mr. Pallas. We're taking a look at Lab 21B, Electrical Energy and Power. So we're going to be looking at voltage and how it relates to the amount of work that is done in each second. 1 volt means that 1 amp of current is being used to do a joule of work. So we're going to set up our circuit here. It's got a single battery, it's got a light bulb, and it's got a switch. And what we're going to do is we're going to measure the voltage first, then we're going to measure the current, and then we will calculate the power. To calculate power, power is the voltage multiplied by the current. So we'll start with getting the voltage across the light bulb, and that is 1.4, let's call it 1.42 volts. And Mr. Pallas will get the amperage.
Remember to open the switch, and the amperage is 0.09 amps.
So it's 0.09 amps and 1.42 volts. So what we'll do is we will multiply those together. Again, power is your voltage multiplied by your current. So 1.42 times 0.09 gets us 0.1278. And what we'll do is we will round to the second place after the decimal point. So that will be 0.13 watts. Next thing we'll do is we're going to take a look at the same circuit, but now we're going to have 2 batteries. So we'll take our leads, close the circuit, and looks like sometimes this happens here. Maybe a battery is in backwards. There we go. Make sure both batteries are going the same way. So let's go ahead and we will measure the voltage here. So it's 2.85 volt. And Mr. Pallas will take a look at the current.
All right, make sure the switch is open. And the current is 0.13 amps. And if you get a negative sign, you can either switch the wires or ignore the negative sign.
Okay. So notice it's a little higher in voltage, and the current is also a little higher here. So we're going to take our voltage, multiply it by our current, and get our power. So 2.85 multiplied by 0.13 gets us a power reading of 0.37 watts. After we get done the first part of the lab, there are a couple questions for you to do, and then we'll move on to part 3, which is energy and power from a battery. All right, so for part 3, 4, and 5, we are going to take a look at a capacitor. The capacitor is in the supercap container, and a capacitor itself is a way to store energy for using that energy at a later time. So the setup here is a battery. Positive end of the battery goes around to a lead wire that does not connect. We're going to use this to charge up our capacitor. The negative side goes over to the negative side of the capacitor here. Here's our supercap. And what we're going to do is we're going to charge this up. Again, it's like a short-lived rechargeable battery. So a couple things to think about as we're going to charge this up and you see what happens. One of the questions here says, hey, what happens when the capacitor is being charged up? Where is the energy flowing to and from? So we're going to take our lead wire and we're going to place it on the posts with the positive end for the supercap, and we're going to count to about 5. This is going to charge up the supercap, and then we'll take this off. What we're going to do next is we're going to close the switch on the circuit, keep an eye out for the light, and see what happens to it over a period of a few seconds. The light is pretty bright, but after a while it starts to dim. The energy is flowing out of the capacitor now, not the battery. So the energy that went from the battery to the capacitor and was stored gets dissipated in the light bulb, or used in the light bulb. So for part 5, what we're going to do is take a look at what's our starting voltage, how many bulbs we're going to use in the circuit, and how long it takes for that bulb to go out. We'll get an average of those 3 trials, so we're going to add the 3 times up and divide that total by 3 to get our average. So to get the data here, we are going to first charge up our capacitor. So we're going to take our lead wire and we're going to place it on the post where the positive end of the supercap is. We count about 5 seconds, so that's about 5 seconds there. And we'll look at our starting voltage. So we're going to take our voltmeter and we're going to put positive, negative on here, and we get a total of 1.45 volts that is being held in the capacitor. Starting volts was 1.45. The number of bulbs here is 1, and we are going to do the first trial. We will give you all the rest of the data after we do this first trial. We're going to close our switch and start our timer. Keep an eye on the bulb. It will get dimmer and dimmer until you can't see it. So at the time that you can't see any light coming from the bulb, you're going to go ahead and stop your stopwatch. That looks like about now. And our first time was 19.71 seconds. So you're going to do 2 more trials with 1 bulb, and then you will add 2 and 3 bulbs. Calculate your average and for the 3 trials, and then you will answer a few questions about what you did. We will give you the data for those trials now. Once again, this is the data for our 3 trials at 1, 2, and 3 bulbs. When you are finished, you can go ahead and answer the questions that go along with this, and that will end up our Lab 21B.